Hello, welcome to the mathematics class of Mysterical Hours Calm. In today's session we are going to start with the first chapter in mathematics. That is real numbers. Now you know the mathematics subject can be classified into three main branches. One is arithmetic, the second one is algebra, and the third one is geometry. Most of the chapters which we are going to discuss in 10th standard are the extensions of what you have studied in 8th and 9th standard. In fact, whatever the major concepts that you have discussed in 8th and 9th class, we are going to continue from where you have stopped in 8th and 9th, so as such you will be studying little bit advanced topics of 8th and 9th class in your temples. And since the syllabus is changed very recently, the concepts of mathematics are made in such a way that the students are prepared in this class itself to track the aptitude examinations or the entrance tests which they will be writing at a later stage. So the mathematics subject is more challenging and it is more rewarding too. Now in today's session, let us begin the first chapter, that is real numbers, and we will discuss the specific topics: introduction to number system as well as the real numbers. Then we are going to discuss about divisibility of integers, followed by the Euclid's division. Before we understand what are real numbers or what do we mean by divisibility of integers, let us try to have an introduction to the number system. So you know mathematics is the systematic study of quantity, that is the numbers, the structure, shape, change, etc. So first let us try to understand what is a number system, what are the different types of numbers, and then we will discuss the actual topic, divisibility of integers. Now what is a number system? The set of the values used to represent the different quantities is known as number system. Now the values which we use in order to represent the different quantities that we come across in our daily life, we call that system of values as the number system. For example, a number system can be used to represent the number of students in a class or the number of viewers watching a certain TV program, the temperature of a place, height of this plant's, weight of the students. Like this you take countless examples. Vary. All these examples involve the quantity representation by a set of values, and we call them as the number system. Now how do we classify these numbers? See, for example, if you take the number of students in a class, it should be a whole number, and the number of viewers watching a television program, again it should be a whole number. And temperature of a place, it can be both positive as well as negative. Then height of plant, it can be even a decimal. So therefore let us try to understand first how we classify the numbers. So the numbers can be mainly classified into real numbers and imaginary numbers. So real numbers and imaginary numbers. So what are these imaginary numbers and what are these real numbers? Anyway, we are going to discuss them one by one, and real numbers can be further classified into rational numbers and irrational numbers, wherein rational numbers can be further classified into integers and fractions. Integers can be classified into whole numbers and negative numbers. And these whole numbers, if you remove 0, the whole numbers will become the natural numbers. So all the whole numbers except 0 becomes the natural numbers, wherein 0 is excluded from the whole numbers. Now if you check the solve, the natural numbers will be whole numbers, and all the whole numbers and negative numbers, and all the integers and fractions, and all the rational and irrational numbers will be real numbers. And all the real numbers and imagined numbers will be the numbers in other words they are represented by the number system. Got it? So what are real numbers? All the rational and irrational numbers put together is called as real numbers. Then what do we mean by integers? All the whole numbers and the negative numbers, we call them as the integers. Then what do we mean by a natural number? So natural numbers are the whole numbers except 0. So now let us see the different types of numbers one by one. I hope you have understood this classification. Very, very important. Okay, so now the natural numbers, say the natural, or they are also known as the counting numbers. There are nothing but 1, 2, 3, 4, 5, etc. like this up to infinity. Infinity means we can go on counting and counting, so there are infinitely many natural numbers, and the set of natural numbers that is 1, 2, 3 or 5 up to infinity. In short, it is represented by the letter capital letter, and so capital letter of the English alphabet. And so therefore young represents the set of natural numbers, and the natural numbers start from 1 and go up to infinity. Now if 0 is included along with these natural numbers, then we get the whole numbers. So the whole numbers are the natural numbers together with C. Then what are integers? So the integers are the set of real numbers consisting of the natural numbers, their additive inverses, and 0. So in other words, the natural numbers 1, 2, 3, 4, 5 like this, they are additive inverse. That means when you add a number with them, you should get 0. So that is -1, -2, -3 like s plus 0. So in other words, the set of integers is equal to 0 plus or -1 plus or -2 plus or -3 plus or -4 like this. So in short, the set of integers can also be written by using the English alphabet I, or it can be denoted as J, or it can be denoted as Z. So I, J, or Z all represent the same. That is the set of integers. Now the sum, the product, and the difference of any two integers is again an integer. So if you add any two integers, take any two integers, for example you take +3 and dash. If you add them you will get 0. Yes, 0 is an integer. You take +2 and -3. How much you will get? -6 when you multiply that. So -6 again it is found here. So multiplication of two integers is again an integer. Subtract any two integers. So work, or what is 3 -5? It is -2. Yes, again it is found. It is that. So therefore the addition, subtraction, multiplication of the integers will again lead to an integer. But this is not so with that division. C, but this is not true for division. Just try 1 divided by 2. For example, if you try 4 divided by 2, you will get 2, but actually 1 divided by 2, it is not found here. So therefore division will not result in an integer. So division of two integers will not result in an integer. Now the rational numbers. What are rational numbers? You all remember all these things, right? You have already discussed in your elementary classes. This is just for your recap solution. So the rational numbers are those numbers which can be expressed as a ratio between two integers. So a rational number is a number which can be expressed as a ratio between two integers, like just now we discussed half. It's a rational number. -4 by 5, it's a rational number. Okay, so in other words, Any number written in the form of p by q is called a rational number. Thus the fractions 1 by 3 minus 1 1 1 1 by 8 are both rational numbers, and all the integers are included in the rational numbers, so all the integers, that's what. All the integers, whether positive or negative, we can call them as rational numbers. Just now we discussed in the child, so why? Because any integer can be written in the form any integer set if you take it can be written in the form of set by 1, wherein it is in the form of p by q, so therefore the set of rational numbers is denoted by the capital letter of the English alphabet Q, which is nothing but equal to p by q, where q is not equal to 0 and p and q belongs to the set of integers, so p and q are integers and q is not equal to 0, though 0 is an integer. Be careful. You should not be equal to 0. What happens if q is 0? Think, if q is 0, then it becomes an indeterminate form. See, you know what is 0 by 1, but you don't know what is 0 by 1. Sorry, 1 by 0 you know. What is 0 by 1? 0 by 1 is 0, but what is 1 by 0? You cannot divide 1 by 0, you cannot. You can divide 0 by 1, 1 0 is 0, you will get, but 1 by 0 it is an indeterminate form represented by the letter infinity. Infinity symbol is the flat 8. Okay, so you should not be equal to 0. Now what are irrational numbers? This an irrational number is a number that cannot be written as a ratio or fraction, so a number which cannot be written as a ratio or a fraction, we call it as an irrational number. See, in decimal form, it never ends or repeats, so an irrational number, if you are writing in a decimal form, it never ends, it goes on and on, or it keeps repeating. That's what we call it as a carrying decimals. Okay, so the ancient Greeks discovered that not all numbers are rational, so this was discovered by ancient Greeks itself, that not all the numbers are rational numbers. There are certain equations that cannot be solved using the ratios of integers, so they call them as the irrational number. For example, root 3, root 5, root a root level, etc. These are called as irrational numbers. Now the real numbers, which is the actual topic of discussion. So the real numbers is the set of numbers containing all of the rational numbers and all of the rational numbers. That is what I told you, all rational and irrational numbers put together is real numbers. Remember, write down the real numbers are all the numbers on the number line, so therefore real numbers represent all the numbers which are found on the number line, and there are infinitely many real numbers, just as there are infinitely many numbers in each of the other sets of the numbers. So when you take all other sets of numbers, you have infinite numbers just like that. In real numbers also, your numbers are infinite. There are infinite number of real numbers, but the infinite set in case of real numbers is really bigger when compared to all other sets. That is what we mean. Yeah, but it can be proved that the infinity of the real numbers is a bigger infinity when compared to the all other sets. Okay, now next, numbers can be classified into real numbers and imaginary numbers. So now, what are real numbers? We have already discussed how they can be further classified, and in fact we started from the bottom and went up to real numbers. Now there is the other classification of numbers, that is imaginary numbers, or they are also called as the complex numbers. So the complex numbers are denoted by the capital letter C and the complex letter Complex numbers set consists of the numbers which are of the form a plus ib, or which are of the form a plus bi such that a and b are real numbers. A and b are real numbers, but the complex number will always be in the form of a plus ib or a plus bi. So for example, if you say 3 plus 4i, that means this is an imaginary number, and what is the value of I? So value of I is root of -1, so the value of I is root of -1, hence it is called as an imaginary number, or it is also called as a complex number. Okay, now let us go to the actual topic of the syllabus, that is divisibility of integers. You all know about division, right? How you divide one number using another number. I hope you remember all these things, right? Why now you should be very familiar with my addition, multiplication, subtraction and division. So you have discussed about manually how to divide one number with another number. In other words, when you divide the dividend by the divisor, what are you going to get? You have seen all this in your elementary classes. Now let us go one step ahead and try to come out with some kind of relationship between these values. Once we divide one number with another number, now we are familiar with the fundamental operation of division. So you are all familiar. You know that one. Now we say a number, one number divides another if there exists a third number such that the second number should be equal to the product of the third number and the first number. Okay, that is, we say for example 3 divides 6, so 3 can divide 6 if and only if there is another number 2 such that 6 can be written as 2 into 3, correct? So therefore, stated in general, we say that a number A divides P if B is equal to K into A for some natural number K, where K is some natural number. So that is what 3 divides 6 if 6 can be written as 2 times 3, that means 2 is a third number, which is another natural number. So then we say that one number divides another number. So this is an important result. So J divides B if and only if B is equal to K. To me, like that. Can you try whether 24 divided? So 4 does not divide 25 because you cannot write 25 as a product of natural number and 4, because you will get 25 will be equal to, that is 6 into 4, which is 24. So one less. So when that means always it is not possible that one number can be completely divided by another number. So there will be a reminder. You know this, right? So therefore, whenever a dividend is divided by a divisor, we get the corresponding and remind. So therefore, whenever a dividend is divided by a divisor, we get the corresponding quotient and the reminder. And these 4 terms, that is dividend, divisor, quotient, reminder, they can be written in the form of a relationship, that is dividend is equal to divided into quotient plus remind. So dividend will be equal to divisor into quotient plus reminder. So if you denote A as the dividend, B as the divisor, Q as the quotient and R as the reminder, then the relationship what we just now stated can be written as J is equal to B into Q plus R. So how can we write it? We can write it as A is equal to BQ plus R, where J is the dividend, B is the divisor, Q is the quotient, R is the reminder. So you can also remember this relationship very easily. J is equal to PQR. So what is A? So you know, whenever we divide in your elementary classes, you have this practice, that dividend, divisor, quotient, reminder. You remember right there will be a dividend there will be a divisor, so once you divide this dividend by the divisor you get the quotient and the remainder, so therefore a dividend b divisor q quotient our remainder, so j is equal to pq plus r, where is the dividend v is the divisor, q is the quotient, r is the remainder. Now take for example, if we divide 13 by 4, what do we get? We get the quotient 3 and the remainder 1, therefore we can write 13 4 into 3 plus 1, so 13 is the dividend, 4 is the divisor, 3 is the quotient, and 1 is the remainder, so that this relationship, oh it's good. In other words, 13 will be equal to 4 into 3, 12 plus 1, 13, so 13 is equal to that, so this familiar relation is named after the father of geometry, the great mathematician Euclid. So you have heard of this great mathematician Euclid. Hence this result, A is equal to BQ plus R is called as Euclid's division lemma, so it is called as Euclid's division lemma. Then what is a lemma? Right, you might be wondering now why suddenly after lemma came here. So lemma is nothing but a minor result whose sole purpose is to help in proving a theorem. So that means this result, what we have now, it will be used in proving a theorem. So hence really minor result that can be used to prove a theorem, we call it as a lemma, and this whatever the formula or the relationship that we have found out. Now it is very useful at a later stage to prove so many theorems, hence it is called as Euclid's division lemma. And a lemma, it is a stepping stone in the path of proving a theorem. So not only we use it for proving the theorems, we also use it to prove lot of the statement problems once we are done with this topic. So this lemma, it is a proven statement which is used to prove another statement. Hence in general we can say that lemma is a proven statement which can be used to prove another statement. I hope now you understood why it is called as Euclid's division lemma. Now Euclid's division lemma, how do we state it? So it is stated as follows. Already we have discussed that only whatever we have discussed that if you put it in the statement form, that becomes Euclid division lemma. So it is a very important question in the examination which will be asked for 1 mark. State Euclid's division lemma. How do we state that? So consider two positive integers a and b, then there exist unique integers q and r satisfying the relationship is equal to bq plus r, where r will be less than b but always greater than or equal to 0. So r will be less than b but greater than or equal to 0. So this is called as Euclid's division lemma. So the statement is very important, and this is a well-known result which was first recorded in the book 7 of Euclid, that is the Elements. So the 7th book written by the great mathematician Euclid. So the Elements, in that this lemma was first mentioned, and there are several applications of this lemma. That's what we were discussing. That lemma, it is a proven statement which can be used to throw another statement. So therefore its applications are many, and using this lemma yet CF of 2 positive integers can be found easily. So now one of the important application which you are discussing in this class about the Euclid's division lemma is to find the HCF of 2 integers, that is the positive integers. This method is called as, since you are using Euclid division lemma to find out the HCF of 2 positive integers, this method is called as Plate's division algorithm. So it is called as Euclid's division algorithm. So Euclid's division algorithm is used in order to find the HCF of two positive integers. What is HCF? Highest common factor. So when you take two positive integers, which is that highest common factor, that means which is that highest number which is common in both these two integers, that factor which is therein both these positive integers that can divide them. So recall that itself of two positive integers a and b is the largest positive integer c, which can divide both a and b. HCF of any two numbers is also called as the greatest common divisor. So the other name for HCF is greatest common divisor. So GCD, HCF both are one and the same. So many times in the examination they will ask find the GCD of two numbers, so you should know that GCD is HCF itself, both are one and the same. It is also called as greatest common divisor. So HCF, that is highest common factor, it is also called as greatest common divisor. Consider the example of finding 40 and 735. Now what is the HCF of this 40 and 735? So we have already learned to find HCF by factorization method. You know how to find itself by factorization method, you have discussed in your previous classes. So first you will note down all the factors of 40 and all the factors of 735, which are the common factors you have in both. We will take the product of them. That is going to be the highest common factor, so you know this. Now let us learn to find the HCF of two numbers by Euclid's division algorithm. So let us find the HCF of 40 and 735 using Euclid's division algorithm. So you know, if you want to apply Euclid's division algorithm, we should use the lemma j is equal to pq plus a. So EA is the dividend, b is the divisor, so therefore consider 40 and 735 and this. Let a is equal to 735 and b is equal to 40. So always take the greater number as a and the smaller number as b out of the two given numbers. So yeah is that dividend, we have to divide this by 40. So therefore when 735 is divided by 41s of 40, so you will get 33. Reminder, take 5, so you will get 48 or 320, and the remainder is 50. Can you divide further? No, because the remainder are, it is less than b but greater than. So here the quotient is 18, the remainder is 15. Therefore by Euclid's lemma, what we can write it as v is equal to pq plus r. Now yes, 735, that is equal to b is 40 and q is 18 plus r is 50. Now in the second step what you have to do is make 40 as the dividend and 15 as the divisor. So what do you get? So consider a is equal to 40, dividend b is equal to 15, that divisor. So therefore 40 divided by 15, so 15 to 30, 10 is the remainder. So we cannot do further division. So therefore here q is equal to 2r is equal to 10 by Euclid's lemma. J is equal to bq plus r. Now e8 is 40, that b equal to 15 into q is 2 plus remainder is 10. Now let us go to the next step. In the next step made 15 as the dividend and 10 alpha divisor. What do you get? So consider a is equal to 15 and b is equal to 10. So 15 when it is divided by 10, 10 ones at 10 and 5 is that remainder. Therefore q is 1 and r is 5. Using Euclid's lemma you can write 15 is equal to 10 into 1 plus 5. So 15 is equal to 10 into 1 plus 5. Now make 10 as the divisor and dividend in the divisor. So Divide 10 by 5, so when you divide 10 by 5 you will get 5 to 10, the remainder is 0. So when you are finding the HCF or the GCD of two positive integers by using Euclid's division algorithm, you should work out the repeated steps up to the remainder, which is going to be 0, so that means until you get the remainder 0. Dividing that to a positive integer. So now you got 0, so here y is 10, that is equal to bq5 into 2 plus 0. Now when you have written the divisor and the dividend using Euclid's division lemma, in each of these steps, which is the divisor that is non-zero divisor, which is the divisor that resulted in the remainder 0, saw non-zero divisor which resulted in the remainder 0, so the non-zero divisor which resulted in the remainder 0, it is 5, correct. So therefore the remainder is 0. The CF is the divisor in step 4. So the HCF of the two numbers, that is 40 and 735, he is the divisor in the last step, so that is what it is also called as the greatest common divisor. So the last divisor is 5, so therefore 5 is the HCF of 735 140. I hope you understood this right. It's very simple. So we have discussed in this session the introduction to the number system and real numbers. Then we have discussed about the divisibility of integers, and we have discussed what is Euclid's division algorithm and how are we going to find the HCF of two numbers using this Euclid's division algorithm. I hope all the concepts are clear to you, right? Still, if you feel that you have not understood any of these concepts or the problems properly, please feel free to post your doubts in the mathematics forum of our website. We are always there to solve every doubts. Thank you.